Imagine standing on a beach where the sand beneath your feet isn't made of silicon and crushed shells, but pure diamond. The ocean in front of you isn't water, it's molten lava stretching to the horizon, glowing red and gold under an alien sky that never changes. Now imagine this entire world, twice the size of Earth, is essentially one massive gemstone hurtling through space 41 light-years away. This isn't science fiction. This planet exists right now, and if humans could ever reach it, the entire concept of wealth as we know it would collapse overnight. Welcome to 55 Cancri E, the diamond planet that made scientists question everything they thought they knew about planetary formation, and made economists wonder what would happen if someone actually brought a piece of it home. If you're the kind of person who looks up at the stars and wonders what's really out there, you're going to want to stick around for this, because what we've discovered about this world gets stranger and more unsettling with every observation we make. And if you enjoy having your mind expanded by the mysteries hiding in our universe, consider subscribing, because we explore these kinds of cosmic enigmas every single week. The story begins in 2004, when astronomers pointed their telescopes at a star system in the constellation Cancer. They weren't looking for treasure, they were hunting for exoplanets, worlds orbiting distant suns, trying to understand if our solar system was unique or just one example among billions. What they found orbiting the star 55 Cancri was a super-Earth, a rocky planet about twice our world's size and roughly 8 times more massive. They catalogued it, measured its orbit, calculated its mass, and moved on. Just another data point in humanity's growing census of alien worlds. But then the numbers started telling a strange story. This planet was too close to its star, circling it once every 18 hours. 18 hours. Earth takes 365 days to complete one orbit around our Sun. This world was practically skimming the surface of its parent star, subjected to temperatures that would vaporize lead, melt iron, turn rock into flowing rivers of liquid stone. Any atmosphere it might have once had would have been stripped away eons ago by stellar radiation. The surface temperature was estimated at around 4,000 degrees Fahrenheit, hot enough to turn carbon dioxide into plasma. Scientists began building models of what such a world might look like. They plugged in the mass, the density, the composition of the parent star, the temperature, the pressure. And that's when something unexpected emerged from the calculations. Based on everything they knew about planetary formation and the chemistry of the star system, this planet shouldn't be made primarily of silicate rock like Earth. The ratio of carbon to oxygen in the system suggested something far more exotic. The models kept pointing toward the same conclusion, one that seemed almost too perfect to be real. Under the crushing pressures and extreme temperatures of this world's interior, carbon wouldn't exist as graphite or organic compounds. It would crystallize into its densest, hardest form. Diamond. Not scattered deposits, not veins running through other rock. The entire mantle of this planet, perhaps a third of its total mass, could be composed of crystalline carbon. We're talking about a layer of diamond potentially thousands of miles thick, wrapped around a molten iron core, covered by a thin crust of graphite and silicates, all of it bathed in oceans of liquid lava. When news outlets picked up the story, they did the math that everyone was thinking about. If you could somehow scoop up just a fraction of this planet's diamond content and bring it back to Earth, you'd be holding more wealth than has ever existed in human history. One estimate put the value at around $26.9 nonillion. That's a number with 30 zeros after it. For context, the entire global economy is worth around $100 trillion. This single planet contains more theoretical monetary value than humanity has generated in all of recorded history, multiplied by billions. But here's the unsettling part that nobody talks about when they're dazzled by the dollar signs. If you actually did bring back that much diamond, it would be worthless. The entire reason diamonds have value on Earth is scarcity, or at least the carefully managed perception of scarcity. flood the market with infinite diamonds, and they become as valuable as gravel. You'd crash not just the diamond market, but potentially destabilize the entire concept of precious materials having worth. Gold, platinum, rare earth elements, all of them derive value partly from being rare. Prove that the universe is full of treasure beyond imagination, and the bottom falls out of everything. Scientists continued studying 55 Cancri E, refining their models, checking their work, because the implications were profound. If carbon-rich planets could exist, it meant our understanding of planetary diversity was still in its infancy. Earth is an oxygen-rich world. Our rocks are mostly silicon and oxygen compounds, silicates, the stuff of sand and granite, and the mantle beneath our feet. But change the chemical recipe of the stellar nebula where a planet forms, increase the carbon relative to oxygen, and you get an entirely different class of world. Instead of water, you might have oceans of tar or liquid methane. Instead of limestone and marble, you'd have carbide minerals that don't even exist naturally on Earth. And at the core of the most extreme examples, you'd have diamond, lots of it, formed not over millions of years in tiny pockets of the upper mantle, but throughout the entire planet during its initial formation. The planet is also tidally locked, meaning one side perpetually faces its star, while the other remains in eternal darkness, just like our moon always shows us the same face. This creates a world of permanent extremes. The day side is a hellscape of vaporized rock and possibly clouds of silicon, literal clouds of what would be sand if it were cooler, floating in an atmosphere that's more like a thin vapor of destroyed minerals. The night side, though still unimaginably hot by Earth standards, might be slightly cooler, though we're talking the difference between a blast furnace and the inside of a volcano. Now imagine this for a moment. You're standing on the night side of this diamond world in some impossible future where humanity has developed a technology to visit. The ground beneath your heavily shielded boots is crystalline carbon, faceted and compressed over billions of years. Above you, there's no sky as we'd recognize it, just a faint shimmer of vaporized elements and the eternal black of space broken by a horizon that glows deep red from the furnace on the planet's far side. You can't see the star from where you stand, but you can see its effects. A permanent sunrise that never moves, painting half the world in light intense enough to melt titanium. The ground itself radiates heat from below, warmth seeping up from a core of molten iron wrapped in layers of diamond that formed when this world was young, and the entire planet was an ocean of liquid carbon, slowly crystallizing as it cooled. What scientists realized next changed everything about how confident we could be in this diamond planet hypothesis. In 2011 and 2012, new observations came in with better instruments, more precise measurements. Researchers looked at how the planet's temperature changed as it orbited its star, watching the way heat flowed across its surface. They measured variations in the star's light as the planet passed in front of it, analyzing what that light revealed about the planet's composition. And the picture got more complicated. Some of the models suggested there might be more water than initially thought, locked into minerals or existing as a supercritical fluid under the immense pressure. If true, it would mean less carbon available to form diamond, maybe reducing that massive gemstone mantle to something smaller, though still beyond anything found on Earth. The scientific community started hedging. Maybe it was a diamond planet. Maybe it wasn't. Maybe it was something in between, a world with significant diamond content, but not the solid mass of crystalline carbon the early models suggested. This is how science works. You make observations, build models, test predictions, and refine your understanding when new data comes in. It's messy and uncertain, and doesn't fit neatly into headlines about treasure worlds floating in space. Then, in 2022, the James Webb Space Telescope turned its powerful infrared eyes toward 55 Cancri E. Webb can analyze the atmospheres of distant planets by watching how starlight filters through the thin shell of gas surrounding them, identifying chemical signatures that reveal what elements are present. The data came back showing possible evidence of a substantial atmosphere, maybe carbon dioxide or carbon monoxide, gases that could only persist if they were constantly replenished by volcanic activity. This suggested an active geology, a planet that's not just a dead lump of carbon, but a dynamic world with a molten interior driving surface processes. Lava flows, gas emissions, maybe even a form of tectonics unlike anything we see on Earth. But here's what that really means. If the planet has active volcanism, if gases are bubbling up from the interior, it changes what the inside looks like. Active geology requires heat and movement, convection currents in the mantle, melting and re-solidifying of materials. Pure diamond doesn't behave like that. It doesn't flow, it doesn't convect. So maybe the interior is a mix, diamond mixed with other carbon compounds, with silicates, with iron, all of it under such extreme pressure and temperature that the neat categories we use to describe materials on Earth just don't apply anymore. This is where the story gets philosophically interesting, because we want 55 Cancri E to be a diamond planet. The idea is almost irresistible. It plays into every fantasy humans have about hidden treasure, about discovery leading to wealth, about the universe being full of valuable things just waiting to be claimed. We've been telling ourselves these stories for thousands of years. El Dorado, Atlantis, mountains of gold, islands of spices, the New World, and now planets of diamond. The narrative is embedded deep in our cultural DNA, this idea that out there somewhere is a prize so valuable it will change everything. But the universe doesn't care about our narratives. It doesn't arrange itself for our convenience or our dreams of wealth. 55 Cancri E is what it is, a carbon-rich super-Earth subjected to extreme conditions, probably containing significant amounts of diamond in its interior, because that's what happens to carbon under those temperatures and pressures. Whether it's 30% diamond or 3% doesn't actually matter to the planet. It's not trying to be valuable, it's just existing, locked in its 18-hour orbit, one face forever burning while the other freezes in relative terms, completely indifferent to the fact that 8 billion humans 41 light-years away are debating its composition. And that distance is critical. 41 light-years. The fastest spacecraft humans have ever built, the Parker Solar Probe, travels at about 430,000 miles per hour when it's at its absolute maximum speed near the Sun. At that velocity, it would take about 65,000 years to reach 55 Cancri E. You'd need multiple generations living and dying aboard a ship, an entire civilization condensed into a vessel, all committed to reaching a world that might kill them the moment they arrived. And for what? To confirm it's made of diamond? To somehow extract value from a place where the surface temperature would destroy any equipment we could build with current technology? To bring back samples that would prove the universe contains more wealth than we can imagine, thereby making wealth meaningless? There's something almost tragic about it. We found a planet that might represent more monetary value than our entire species has ever created, and it's completely inaccessible, locked away by the tyranny of distance and physics. We can see it, we can study it, we can build models and make predictions and argue about its composition, but we can't touch it, we can't mine it, we can't bring it into our economy. It exists as a taunt, a reminder that the universe is full of wonders and resources beyond measure, and almost all of it is forever out of reach. Now think about what this means for the future. Right now, we're still in the early days of exoplanet discovery. We've found thousands of worlds in the last 2 decades, and we're just scratching the surface. There are probably billions of planets in our galaxy alone. Some will be diamond worlds. Some will have oceans of liquid methane. Some will rain glass sideways in hypersonic winds. Some will have mountains of pure metal, entire continents of gold and platinum created in the supernova explosions that seeded their formation. And we're going to find them all eventually, catalogue them, measure them, understand their compositions. We'll know exactly how much treasure is scattered across the galaxy, all of it impossibly distant, all of it useless to us except as data points and sources of wonder, unless we change. Unless we develop technology that breaks the current limits, faster propulsion, generation ships, maybe something we can't even imagine yet, that turns interstellar distance into a solvable problem rather than an absolute barrier. If that happens, if humanity ever reaches the point where we can actually travel to these worlds and bring back their resources, we'll have to confront an uncomfortable question. What happens to an economy, to a civilization, to the entire concept of value when scarcity disappears? When you can go to 55 Cancri E and scoop up diamonds by the ton, when you can visit metallic asteroids and return with more platinum than has ever been mined on Earth, when every rare element becomes common because space is full of it, what's valuable anymore? Maybe nothing material. Maybe the only things that retain worth are the things that can't be found on other planets. Human creativity, relationships, time, experiences. The things we already know are valuable but constantly forget because we're distracted by shiny objects and the pursuit of scarce resources. It's possible that the Diamond Planet and all the treasure worlds we'll discover represent a future test for our species. Can we grow up? Can we move beyond the scarcity mindset that's driven human conflict and competition for our entire history? Or will we take our worst instincts with us to the stars, fighting over who gets to claim the diamond planets and the gold asteroids? Just colonialism and resource extraction on a cosmic scale. Here's a question worth thinking about, and you should drop your answer in the comments because I'm genuinely curious what people think. If we develop the technology to reach places like 55 Cancri E and bring back unlimited diamonds, unlimited rare materials, what do you think happens to Earth's economy? Does it collapse into chaos, or do we finally move past material wealth as the primary measure of human value? Because that's the real question this planet forces us to ask. And if this story made you think about space differently, about wealth differently, about what actually matters, share it with someone who needs their perspective shifted. These are the kinds of conversations we should be having as a species, because the universe is stranger and more abundant than we ever imagined. And that abundance is going to challenge every assumption we hold about scarcity and value and what it means to live in a finite world surrounded by infinite resources we can't reach. 55 Cancri E is still out there right now, completing another 18-hour orbit around its star, surface temperatures hot enough to melt rock, interior possibly filled with more diamond than humans have ever seen, completely unaware that it's become a symbol for everything we want and everything we can't have. Scientists will keep studying it. New telescopes will gather more data. We'll refine our models, argue about the percentages, maybe eventually prove definitively whether it's really a diamond world or just a carbon-rich planet with our projections and hopes crystallized onto it. But in the end, the most valuable thing about 55 Cancri E isn't the diamonds. It's what the planet reveals about us. Our obsession with wealth, our tendency to measure worth in terms of rarity and possession, our inability to see something beautiful or unusual without immediately asking what it's worth, how we can own it, what we can do with it. The universe is full of wonders that exist for no purpose other than to exist, sculpted by physics and chemistry over billions of years, indifferent to human concepts of value. And maybe that's the real treasure, the reminder that worth is something we assign, not something intrinsic. A diamond planet is only valuable if you're a species that decided diamonds matter. To the cosmos, it's just another world, one arrangement of atoms among countless others, no more or less significant than the rock you're standing on right now. And that thought, more than any amount of crystalline carbon, is worth holding on to as we stare up at the stars and wonder what else is out there. waiting to teach us that the universe is under no obligation to make sense to us or care about what we think is precious.